All right, guys. So you probably want to make a few notes along the way here. I think you guys have realized by now that some of this stuff gets given away, okay, as we go along. So write it down, and then when you're actually putting your final lab report together, what should you be doing? Right, okay? You don't even really have to be watching it, you can just be listening to it in the background, okay? Because most of the stuff I give away is kind of auditory. All right, so the problem we're investigating here is this. What's the evidence that we have that a reaction takes place when substances are mixed? Okay, the other stuff there is kind of background. When substances are mixed, the chemical properties of each material determine whether a reaction will occur. Okay, so how do we know that that a reaction has occurred? That's the problem that we're investigating. Okay, and we talked about, the first day we talked about reactions, the signs of a chemical change. All right, what were some of those signs? Andres? Temperature change, okay, energy change, either up or down. Okay, what else? Precipitate formed, okay, somebody else. Color change. Okay, state change, odor change, okay? All of these things are signs that something new has been formed, because now the physical properties that we see are different, and the only way physical properties can be different is if there's new material. All right, and so that's what we're investigating in this lab. Okay, what we're going to do is pair up a bunch of different combinations of these materials. All right, and we're going to see if there's any of those signs. Right? Is it possible that there will be more than one of those signs in any chemical reaction? Okay, it is very possible. Okay, it's possible that you can get a gas evolved and a state change. Okay, it's entirely possible. There's probably going to be a few where you get two signs. Okay, precipitate and color change often go together. All right, so things to watch for there. All right, so our design and variables here, remember, we're identifying, manipulated, responding. How many controlled? 3, okay, 3 controlled variables. Okay, so 3 controlled variables, and explain your choices, okay? And okay, we know now after the first lab the level of detail that's expected in our explanation. It can't just be because that's what I changed. Or because it has to stay the same, right? Or something like that. So we're definitely looking for a little bit more, okay, when it comes to that. Now, we just said that what we're doing in the procedure is trying different combinations, okay? Are we picking those? Yes. I know it's given to you here, but we picked those. We're the experimenter. We're the ones mixing here, agreed? Okay? Why do we want to mix different materials for? If I mix the same 2 things, am I ever going to see any different signs of a chemical change? That's why I got to mix different things. If I want to find out what are some signs of a chemical change, I've got to see a bunch of different chemical changes. I can't just run the same reaction over and over again. Okay? That's why we want to use a bunch of different combinations of materials. Is that a big enough hint for one of the variables? Okay. All right. What are we watching for? Well, we've said that a bunch of times. We want to find out what the signs of a chemical change are. Okay? And it probably depends on what we're mixing together. Right? Now, things that are controlled, okay? Things that are controlled in this lab need to be things that could affect how fast or how well a reaction occurs. All right? What kind of things would affect that is what we need to think about. Okay? I'm not going to give them away. Those are what you guys are going to figure out. Okay? So anything that could really affect the rate of reaction, whether a reaction occurs or not, okay? Those kind of things, those certainly need to be your controlled variables. And many of them are environmental. All right? Okay, for our hypothesis. Okay? The if part of our hypothesis should probably talk about what a chemical reaction is. Right? Because we know the then part is going to deal with this. Okay? The then part of our hypothesis is going to deal with the evidence of a chemical change. Okay? So the then part should say, then these are the signs. Okay? This is what I'm going to see. Right? But the if part should talk about what a chemical reaction is. Okay, something like that. Or or a chemical change or something along those lines. You need to, in the if part, talk about what that is. Okay? The and part, as always, describes our experiment. Okay? Look at the procedure and summarize. The then part should talk about what you'll see, okay, if a chemical change or a chemical reaction occurs. It always describes the experiment. Brief summary of the experiment. Okay, now on this part here, initiating and planning. We didn't have that on the last lab because you had to design the procedure. The procedure is done for you in this one. Okay, when you get the Chromebooks, you'll see that the template I've made has an initiating and planning chart. All right, and in that chart is the numbers of the pairs. So pair 1, pair 2, pair 3, pair 4. Okay, and it has it asks you what kind of reaction you think will occur, and it has the reactants written. What you have to do is predict the products. All right? So it's okay if we're wrong. Right? It's okay if we're wrong. If we don't predict the products right, that's fine. In the analysis and in the conclusion, we can say, look, our predictions were that a double replacement reaction was going to happen, but that's not what happened. Okay? Something else happened because a gas came out, and you can't have a gas in a double replacement reaction because that's a molecular compound, and replacement reactions are only ionics. You know, so you have things to think about there. All right? It's okay if we don't predict them right. They're just predictions. Okay? What we have to do later is say, why weren't they right? All right, does everyone follow me on that? So that part will be fairly straightforward. It's just like what we've been doing for the last few days, okay, is predicting the products of a chemical reaction, balancing the reaction, etc. Okay, and then after that, there'll be the procedure, the materials, the procedure, and then the observations chart, okay, already built for you. You might want to make a copy of that, print it off over the weekend or something so you have something to record on Monday when we're in the lab. And obviously you won't be able to do anything past your predictions. Right? So all I'm really expecting for you to get done today is problem, design, hypothesis, initiating, and planning. All right? Now, when we get to the analysis part here, I know we can't do that until we have actual data, but when we get to it, okay, it's asking you to write in words and formulae. Okay, so write it out. Let's say, I don't know, like this. Okay, it's saying write it out in words and formula. So write it out in formula form. It looks like this. Okay, so you'll write out each reaction like that, which for most of your reactions will just be copying and pasting from your predictions, because I'm quite certain that you'll predict most of the reactions correctly, right? So that part's easy. But then you're also going to write it out in words. So hydrogen chloride plus sodium hydroxide gives water and sodium chloride. Okay, everyone follow me there? And the reactions have to be balanced. This one's obviously all ones. Okay. And then, and obviously you don't have to do pairs 4 and 5. Okay, I've already done pairs 4 and 5. When you get your template, pair 4 and 5, the reaction is already written out because it's not a reaction type that we've gone over. Okay, so there is no way you would have ever known what to do with it. In fact, I had to look it up. Okay, a few years ago when I first did that. So, okay, you don't have to do those ones. Number 2, okay, 2 of the reactions in our lab, 2 of them, are going to produce precipitates. Okay, you need to identify from your observations which 2 reactions those were, and then using your solubility chart, determine what the precipitates are. Okay, so looking at your products, find out which one is insoluble, okay, and tell me what the 2 precipitates produced in the lab are. Okay, everyone follow me there? Right, so you'd say, you know, pair 1 and pair 5, or whatever it happens to be that produced the precipitates, okay, and they were, I don't know, I can't even think of something that's insoluble off the top of my head, okay, these are the 2 compounds that were precipitates, okay. All right, so that's what you have to do for the analysis. Conclusion, same as always, okay, restate your hypothesis by copying and pasting, okay, and then using your results. Okay, did you see all the signs of a chemical change that you listed in your hypothesis? If they're all there, great, your hypothesis is acceptable. If there were any that you missed, okay, explain maybe why they weren't seen, okay, something like that. Sources of error, how many? 2 sources of error. 3 controlled variables, 2 sources of error, okay, and don't forget to list or suggest improvements. Okay, don't just say these things were sources of error, okay, make sure you tell me what could be done better. Alright, the class discussion questions, same as always, do not have to be done, okay, on your lab report, but we will go over them, okay, as a class when I return the labs. Okay, are there any questions on that? Alright, we'll get started. No, Hayden? Then needs to talk about the evidence of a chemical change.